This is question 7 from test 4. Here we have two blocks, A and B. A has a mass of 3 kilograms and B has a mass of 6 kilograms. Between both of the blocks there is a spring. The blocks are forced together, compressing the spring, and then they are released. When the blocks are released after the compression, the block B gains a velocity of 1 meters per second. And they are asking us to find the velocity that A gains. What is the final velocity of A? And also, what is the amount of potential energy stored in the compressed spring when the two blocks are faced together? So we are going to use the initial momentum is going to be equal to the final momentum. We're going to use this equality. The initial momentum is going to be 0, and the final momentum is the mass of the block A times the final velocity plus the mass of the block B times its final velocity. Here we don't have the final velocity of block A. That's the thing that we're trying to find the value. So we pass the mass of block A times the velocity of block A to the left side, so it's gonna become negative. Then we have to divide both sides by the negative mass of A, so the velocity of A is gonna be alone in the left side, so the equation is going to become like this one. Negative mass of B is divided by the mass of A times the final velocity of the block B. So we plug the numbers. Negative 6/3 multiplied by 1 is gonna give us negative 2 meters per second. That's the final velocity that the block A gains when they are forced together and then the release. Now they're also asking us to find the potential energy stored in the compressed string. So we're gonna say that the initial mechanical energy is going to be equal to the final mechanical energy. The initial mechanical energy is the potential energy of A plus the potential energy of B plus the kinetic energy of A plus the kinetic energy of B plus the initial potential energy equal to the kinetic energy of A plus the kinetic energy of B plus the final potential energy. Both of this value is 0 at the beginning, plus the initial potential energy, which is 1/2 k times x squared. The kinetic energy of A, like the final kinetic energy of A, is equal to this equation. B is the same, plus 0, because the potential energy, the final potential energy is 0 because the system is released, so there is no potential energy. So U, which is this equation, is going to be equal to 1/2 times 3, the mass of the block A, multiplied by -2, which is the final velocity that we just found before, to the second power, plus 1/2 times the mass of B, 6, that times the final velocity of B, 1, to the second power. We do all the calculations, so U is going to be equal to 9 joules. That's the amount of potential energy is stored in the compressed string. So the correct answer for this question, for question number 7, is B. The final velocity of block A is equal to -2 meters per second, and the potential energy stored in the compressed string is 9 joules. That's the answer for question 7.